This is a demo of the vibe-coded trivia app. Here we have two screens. One will be the host and one will be a player. And I also have the game on a mobile device to represent another player. As the host, you can create a game, give the room a password. Here you have two teams by default, but you can add more. You can change the color of the teams and the name as well. For the questions, you upload them as a JSON file, and inside the JSON, you give the question title, four possible options, with one of them being correct, and the time limit on each question as well. Once the game is created, you get this random code you can share with your players. The players can go to the home screen, click join the game, paste in the code, input a name, enter the password, and pick a team. I'll do this on the mobile device as well. The host can see the players joined and start the game when they are ready. So the host has the control of the pace for each round. They can end the round earlier if they want. And the player at the end of each round will see whether they got the answer correct or wrong. And the correct players will see their points. And the point system is dependent on how fast they get the correct answer right. The next step is the host show the leaderboard to the players. And there are two leaderboards. One is individual, and the other is the team leaderboard. The host can see the same view as well. And at the end of the game, this is the final leaderboard where each player will see their individual scores or the team leaderboard. And that is the vibe coded trivia app. Here are the 4 steps I've taken to vibe code this trivia app. By all means, this is not the only steps you should take to vibe code something. If your app grows in complexity or serves a different purpose, then you should definitely look into other steps you should take to safeguard your system, to verify its output and etc. But just for my use case, these are the 4 steps I've taken. You can think of these 4 steps as a beginner-friendly guide on how to vibe code something. The first step is the initial planning stage. And at this stage, there's nothing to be coded yet. It's more of the developer or the agent conductor to really think deeply about how simple can they make the requirements and yet still deliver the necessary features. So basically, the summary of this step is reduce complexity. And just to give a few examples where what I've done in this step to reduce complexity, first of all, I knew that I wasn't going to host this app on any platforms. I would just host the trivia app in one session internally to my colleagues. So something like a Cloudflare tunnel or ngrok would be enough. The database, I wanted to be as simple as possible as well. Initially, I didn't plan to use a fully fledged database like Postgres or MongoDB. I just wanted to store things in a local JSON file. That would be enough. Although that didn't work out exactly, and during the later pivots, I changed the database solution to Supabase, but that's something I'll go into later. Another decision I made in this stage was to pick an AI-friendly stack. By that, I meant picking the technologies that I know AI models are well trained on. For example, React.js, Next.js, Tailwind, Node.js. Like these technologies are well known, and there are many open source code available. So whatever models that you pick, they generally produce a good output of these type of tech based compared to if you pick something niche. So all these decisions are something I've made in this step. And again, the goal of this step is to reduce complexity. The next step is what I call bootstrap. In this step, you want to scaffold a base project with the tools that you know and are familiar with. For example, few things that I've put in this bootstrap stage is using the Create Next app, Myth, Biome for linting, agent.md, skills, and etc. So the goal of this step is to set out a foundation of the tools that your agents can rely on to safe check its output. For example, Biome with the linting will give feedback to the agents later on about any possible mistakes that they've made. The agent's MD and skills will provide extra capabilities to the agents when they need to do further research on themselves. And again, for my project, for this vibe coded app was quite simple. So I didn't have any testing in places. But if you have a project that requires extensive testing, here's also the place where you might set up something like Playwright, snapshot testing, integration testings, etc. Just scaffold out the basic stuff here in this step. Personally, I like to do everything myself in this step for several reasons. The first one is based on my experience. if you ask the agents to scaffold this step for you, they tend to output versions of libraries and frameworks that are slightly out of date. This is just because their data are trained historically. So it's always best to do this step yourself so that you make sure that you follow the latest versions and the latest best practice and etc. The next step is what I call the initial prompting stage. Now, this is really where you want to generate a long and detailed prompt for the agent. And personally, I use at least two models to generate that initial prompt. As of today, I use Gemini 3 Pro for the initial stage. So when I have the idea of the product and technical requirements from this initial planning stage, I will go to Gemini and dump that list of thoughts into Gemini 3 Pro. And the text there doesn't have to be formatted, in any particular ways, but I would just want to be as detailed as possible. And often I also kind of pause, review, and go back and edit that initial prompt for Gemini. And the reason I use Gemini here is because I like it for tasks such as reasoning and initial analysis. For coding and agentic tasks, I haven't find Gemini that useful, but these models, they are always changing and I could be wrong in the very near future. So this is something that the developer, or again, the person who's in control of these agents and models, this is something they have to experiment every day. They have to try out these different models, understand what their capabilities are, and understand these kind of intricate details within these models. And again, that's something that's essentially, in my opinion, that's the job of the developers nowadays, that they have to keep up to date with these models, understand the intricacies and the details of these models, because the new versions are always being released. So something's always changing. So keep up to date with these models, have a rough idea of use which one for which type of tasks. And then when they do the actual implementation and execution, use the models that they feel is the best for each task. So just back to this initial prompt stage, I use the Gemini 3 Pro to ask Gemini to generate another prompt template, which I can give to Claude Opus 4.6. Because Claude Opus, as of today, is the latest agentic models from Claude, and they really excels at agentic coding tasks than the other models. So yeah, so I use Gemini 3. You can, I sit on my, I sit there, spend maybe half an hour typing out a list of requirements, product, technical, or anything that I can think of. I pause, I revise, but doing this step, I'm just in I'm just within the Gemini 3 model screen, and then my instructions will be to tell Gemini to give me a explicit and detailed prompt so I can give to Opus to vibe code an app. And eventually Gemini 3 will give me a big list of text that I can copy paste into Opus so that Opus can kickstart its agentic session. And for my vibe coded app, you can see the exact prompt that I gave to Quad Opus in my blog. For this last step, pivots, this is essentially where the developer, a human reviewer, or other agent reviewers that have to verify the output so far meets the desired outcome. And to do that, it doesn't mean that we have to review through every single line of code that the agent has outputted. Because in my experience, the agents will output so much code that if you were to review every single line of code, that it will actually add so much mental burden and you'd be so overwhelmed that you would do a bad job at manually reviewing each line of code. So a better way is just verify the behavior of the final product instead. In my case, I didn't review any single line of code the agent has outputted. I simply just spin up the local dev server, go to the trivia app, start going through the flow, and just play the game as if I was the host or the player. And if I spotted any bugs or any glitches within the game, then I would essentially go back to one of these previous steps and reiterate and fix that behavior until it meets my requirement. So essentially, this step is repeat previous steps. Now, just to give more examples of what I did. So for example, I mentioned I wanted to use local JSON files and server-side events and Cloudflare tunnels in my initial planning, because I think this would be a simple enough stack to host the trivia app. But after the initial prompt, the game didn't exactly work based on this architectural backend. So I had issues like game state would not load, as the player would not join, and the questions would not load, etc. So I knew there was something wrong with this backend, and I knew I had to switch or make changes to the backend architecture. And personally, I've been playing around with Supabase in some of my other side projects. So I know I can swap out this entire backend with a more Supabase aligned architecture. But even making that decision, I had to think about how to reduce the complexity. For example, Supabase / Postgres, they have features like row-level securities, schemas, migrations, and often you want to pair them with a Node.js ORM. sign ins, there's options like email password, OWASP, etc. So again, I couldn't just tell the agent switch to Superbase and that's it. I had to kind of know what Superbase offers and what decision points that I have to make and the likelihood of the success of the migration success depends on my initial requirements or definitions of this new Superbase backend. So in this step, I came up with the plan that for Superbase, I don't want row level securities. I just want to use anonymous sign-ins and no ORMs because I think that would just add another level of complexity. Raw SQL migrations will be fine, things like that, etc. So again, that's something I had to make. Just go back to this planning stage. In the future, you could have agents to do this planning stage for you. But again, I would say there's always a probability that the agents will output different configurations every time. So if you know what exact configurations matches your product requirements, it's best that you pick that configuration yourself. So that's an architectural pivot decision that I made in this stage. Scratched the custom backends that I initially planned, switch database, reduce complexity, and then because I switched database, because I switched to Superbase, I added some more safeguarding techniques like Superbase best practice skills that I found that were published by Superbase team on GitHub. There are probably other few things I can add here as well. But again, this is something that you can kind of go back to the code base and implement it yourself because these safeguards will be used throughout the agent sessions and the agents will use these new tools and new skills to verify its own output and etc. And then go back to the prompting stage, tell the Opus, I want to migrate the code base to Superbase, use disable row-level security, use anonymous sign-ins, etc. But also a key thing that I forgot to mention is in this prompting stage, personally, I use Cursor. And I almost always use the plan mode. Because in the plan mode, I want to verify the plan document first, really carefully trying to spot any architectural decisions that I don't think is the right fit for the scope. And in the plan mode, the agents will also ask you questions back. Like, here's a question about a decision. Here are a few options. Which one would you pick? So these two modes are my favorite way of reviewing the agent's work before. So use the plan mode, verify the documents, and use the options feature as much as you can. So after this plan mode prompting stage, go back to the verification stage. Again, for me personally, I've just manually play through the game, but for your app, you could add in auto verifications and auto testings through other methods, etc. But essentially, this will be the majority chunk of our agentic work will be based on during this pivot stage. And after several iterations of pivoting, eventually, again, just for this trivia app, after 2 or 3 hours of pivoting, eventually the game worked. I could host the game, play the trivia questions with external players. I could see the leaderboard. The UI works. There weren't any bugs that I could spot. And that's when I decided the trivia app is done. And that's when I ended the vibe coding session. Again, yeah, this is just a rough overview of what I did to vibe code this trivia app. For your use case, it's best, you probably take different steps than me. And if you're interested in about this trivia app, but in a text blog form, you can check out the link that I've shared and read some of the exact details that I've done.